Okay, so what is content addressable storage? Well, it's a pretty fancy term, but the idea is quite simple. So what it means is you can address or identify content or information by what is stored within it. So if you were to take, for instance, a string, one way you could find an identity for this is to use a cryptographic fingerprint like SHA-256. So we can put this content through a fingerprinting algorithm like SHA-256, get a unique identity for that content. So if we were to ever come across this string and take that fingerprint, we would have an identity for it. We'd be able to look it up and know that that series of bytes represents this fingerprint, or this fingerprint represents those series of bytes more correctly. So if we were to change just even one byte in input, we would get a dramatically different fingerprint. You can see that this fingerprint doesn't match that fingerprint. So it's a pretty simple idea. Great. So now we know what content addressable storage is. Let's take a look how to use it to keep track of file system changes. So say we have a production server, maybe it has some files in it. We can again use the OpenSSL tool to create a fingerprint or a digest for each of the files. So we can see that service A here has a digest that starts with 3BDD, for example. Now, if we were to go ahead and to change one of these files, as if we were just to add a character, say, oops, rotate that digest again, we can see that the previous digest for service A was started 3BDD, and now we can see it starts 49F8. So we have a different digest because it's changed. So now we know how to identify each of these files, and when that digest changes, we know that that file has changed. So with Kosli, we can track these things. So we have a CLI which will produce essentially a manifest for the files in an area of the file system you care about. So again, we can see that service A has this 9F8 digest, which was the same as the digest that OpenSSL gave us. So we can produce this manifest of what was running. And this manifest is what we call a snapshot. This is a snapshot of the file system at this point in time. So if I take off the dry run flag, and I can go ahead and send that to Kosli, if I was to go over now to my production server, I can see that versions of those files are running here in, we have this record building up over time of the different SHAs of the different files that are running in this directory. Now, for instance, you could have this run in the background or as a service on your system. And every time we were to, for instance, say we wanted to change service B this time, make it a bit bigger than it was before, for example. And what we'll find is that a new snapshot will be sent to Kosli, and it will show up in the change log for that server. And we can see here that service B has changed. The previous version has stopped running. We can also see that there was a swap file created in the meantime as well. So this gives you an idea for how Kosli tracks changes using the cryptographic fingerprints or content addressable storage of system. So we've been looking at file systems, but the same methods work when we were looking at tracking Kubernetes clusters, Docker hosts, S3 buckets, Lambda functions. Basically anything that you can represent or address with a SHA, you can track change for.